Hey folks, Doc here. It's mighty chilly outside today. It's about 5 or 6 degrees Fahrenheit. It's cold. I'm on my way out to the shop. I've got the fire burning, and today is the day we are going to dock lock Fugazi's Peerless 820. Stick around. Alright, so here we are in the shop, and we're going to do a dock locker in the Peerless 820 Transaxle that's going in Fugazi here. Now, my usual MO, I know I made one exception, but my usual MO, my whole concept for the dock locker is to get rid of the spider gears effectively and replace the two half shafts with a solid piece of axle shaft. And the idea there is you can't break spider gears that you don't have. Typically the spider gears are sintered steel, and sintered doesn't weld well no matter how good a welder you are. It's just a crapshoot. It's just you're welding together garbage. And the aluminum pancake transaxle cases typically aren't very strong, although the 820 is a little bit stronger. So the idea being is to get rid of some of the parts that are more likely to break or break away, and to add strength to the case by taking away a leverage point. When you've got two half shafts in a transaxle case and they're trying to do this, you've got this leverage point in the middle. Well, it's actually offset to one side, more likely to break the case. So we're going to swap in a 1-inch live axle, a piece of 1-inch keyed shaft, and we have to come up with some sort of arrangement to drive it from the bull gear without the spiders. If you watch my Dock Locker 2.0 video, let me rephrase this. If you haven't watched it, I recommend stopping this video, going to my Dock Locker 2.0 video and watching that. And that kind of gives a little bit of background on the hub that I'm going to use and kind of the methodology behind it. I am using the exact same hub for this one, so the same part number applies, same dimensions apply. In this video here, I am going to be welding it. You don't have to, and I'll explain that as I go. Basically, at this stage of the game, I have no reason not to weld it. My welder is powerful enough. I'm going to be welding mild steel to mild steel, so there's no threat there. You can go through the extra process. It's a little bit more manual labor, but you can go through the extra process to do a non-welded version of this 820 dock locker. I'm going to go ahead and weld it. So let's crack into some parts, and I'll show you what I had to do. This one does carry a little bit more difficulty than an MST or 930. And I'll show you why right now. Alright, so here on the bench we've got a factory 820 differential assembly. You'll notice that unlike the MSTs and the 900 series, the carrier completely encloses the differential, and we have to get inside this carrier to do what we're doing. I'm going to assume that you've already taken your transaxle apart or know how to take it apart. I'm not going to go through that. Alright, so what you end up with here is a half shaft with the side plate and the side gear, and these are retained together. This is kind of grody in here, but clean this up a little bit. These are retained with a C-clip, and you'll have to take out that C-clip. And this kind of demonstrates what the inside actually looks like. So you've got a cross pin with a couple of blocks and the spider gears that just kind of indexes in there. Just pull that out of there. Sometimes it's a bit of a snug fit. And there you have it there. And then the bull gear is kind of grease glued to the side plate. Wow, that's on there. Okay, hang on a second. Need a hammer. There we go. Alright, so same deal here. We've got the assembly apart. Now the idea here in typical Dock Locker 2 fashion, here's the bull gear I've already cleaned out. The idea here in typical Dock Locker 2 fashion is to take one of these weld-on pulley hubs. Again, please refer to the previous Dock Locker 2.0 video, although I'll throw some information in the comment section or in the description section of the video. And the idea being is to get that in there, sandwiched between the side plates, and use some steel keys to index these slots in the bull gear to this hub. So what's going to happen is the bull gear drives the keys, which drives the hub, which drives the axle. And that's all fine and good. Now, there is a difficulty along the way. The differential side plate is where things get difficult in trying to run a straight axle in an 820. Now, there's a company out there, good lord, I think it's EC Carburetors, that has offered a straight axle kit for sale. I've been on the website recently and it says not available, out of stock, whatever. I don't know if they have to make more or if they're no longer offering it. And what they do is they basically offer 2 new side plates and a section of key stock and blah, 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 blah. The difficulty that we run into here, and this is where things really, truly are difficult, is that it requires a little bit of modification. This is the side plate that I just took off the differential a minute ago. This is the one that I've modified. See the difference? I'll show you the difference up close. This is a section of 1-inch axle. Problem. This is my modified one. Solution. Here's the deal. Back to the factory one. You don't see it when it's assembled, but these clever little bastards, and I say clever although it's obnoxious as hell, have machined the factory axle shaft down to 7/8 of an inch where it enters the side plate of the differential. So what you have here is a 7/8 inch hole, and the whole dock locker thing, I want to use a 1-inch axle shaft. She no fit. So I've had to drill out these side plates to 1 inch so that they will fit on a 1-inch solid shaft. This is actually something I did in my own shop with nothing more than the drill press and a couple of bits. You could farm these out and have a machine shop do it. I don't know what it's going to cost. I wasn't willing to spend that money. I did, to be fair, buy new drill bits for this. It probably would have cost me about the same to have it drilled out. I don't know. I spent 50 bucks on a set of Silver and Deming drill bits. I'll show you the kit in a second in order for me to do this. And this is obviously not the last time I'm going to drill big holes, so having a big set of drill bits doesn't hurt me none. I ended up going to Princess Auto and buying this set of bits here. And as you can see, it goes from 9/16 all the way to 1 inch. There's a set right there. So they've got a 1/2 inch shank on them so they'll fit in your drill press. That's the 1 inch bit there, and that's what I used to make the final hole. If you are going to do something like this, I'll tell you how I did mine, just so you get an idea. What I did is I took the 7/8 bit and I chucked it into my drill press. And then I ran the bit down right into the side plate and just held it there and clamped the side plate down over a block of wood on the drill press so that it would be centered, right? Run the chuck up and down, the bit goes in and out of the center, perfectly centered. There you go, now it's centered and you don't have to worry about being concentric. So I took out the 7/8 bit, put in the 15/16 bit, and drilled it out to 15/16 without removing the plate from the table. Once I had the 15/16 hole cut, I chucked in the 1 inch drill bit, again without moving it, and just went ahead and, you know, not pushing hard, lots of lubricant, and drilled them both out. I bolted the assembly together with the shaft going through it to make sure that I got it concentric, and it is. So that's a win. If you're slow, careful, take your time, you know, get it clamped down centered, you'll be fine. This piece is a casting. It's not sintered. It's cast iron, I believe, but I don't really have the ability to tell cast iron from cast steel. Either way, it's a soft enough material that drilling this out was not a problem. Okay, so with that out of the way, we can move on. Okay, so now that we've gotten the differential side plate business out of the way, it's solved, we can move on to driving this thing. So our basic assembly is going to look like this. You know, we're going to have a side plate, and the bull gear rests on there. Notice that there's an index. And then this hub is going to ride inside there. And this goes on top. Now, quick point here. This hub does not fill the entire void. If you're going to do this weldless, you're going to want to pick up some 1-inch washers just to fill the void so that the hub and the axle shaft can't walk around inside there. Because of the fact that I'm doing this welded with keys, and the keys are going to be cut to a specific dimension, and I'll show you that in a minute, it can't move anywhere, so I can skip that step. So what's going to happen here, if I can just hold the assembly up like this, obviously I'm not really holding it concentric, but we're going to fix that, is we've got to cut 2 steel keys that are going to go in here and weld to the hub. Again, if you're going to do this weldless and you're going to notch the hub and insert keys, you'll have to make the keys thicker to account for how much you're notching out of the hub. In the meantime, these slots here are 3/4 of an inch wide. So you got to go rummaging around through some steel and find some steel that, in one dimension is 3/4. I mean, you could cut it from bigger, but you don't want to have to cut all 3 dimensions. I didn't want to have to anyway. So I went digging around through my crap, and I found this trailer hitch drawbar, and this just so happens to be pretty much bang on 3/4. I haven't deburred it, so I don't know if this is going to work, but I'll just stick it in there to show you that it fits rather nicely. So all I have to do is I have to cut it for length and cut it for thickness, make 2 of them, and essentially end up with a pair of these. So this is going to sit in there. I'll bring the camera in overhead afterwards, and the keys are going to go in here, and the whole shooting match is going to ride inside there. Okay, so your 2 keys for the weld-in, right, because if you're going to slot the hub you got to make them thicker. Your 2 steel slugs, your 2 keys for the weld-in have to be 3/4 of an inch by 3/8 of an inch by 1.25 inches long. And the reason that we want the specific length of 1.25 inches long is to keep the whole assembly from walking around inside. So you can see that you've got this ridge here on both of the side plates, and the index into the bull gear. So basically what I had to do was measure the space from that ridge to the other ridge so that this key gets sandwiched between the 2 side plates, and that's 1.25 inches. Now for setup, I'm just going to go ahead and drop that on there, and I'm going to plop the hub inside. Actually, tell you what I'm going to do, I'm going to space that up a little bit here just so it shows a little bit better. There we go. Just drop that in there so it shows a little bit better. So for setup, I'm going to go ahead and bang those keys in there. And I found that if I use a bunch of 5/16 bolts, they take up the space pretty well all around that hub. Not exactly bang on perfectly, but pretty well. And if each of those bolts is just very slightly loose, you can bet that you've got this thing concentric enough. Those bolts are obviously not going to stay. That is just so that I can get a couple of tack welds on the keys, flip the thing over, tack weld the keys, and then burn the whole shebang in. What I'm going to do after I get the first 2 initial tack welds on is I'm going to pull the assembly apart and test fit the axle and test fit the assembly just to make sure that it can go together without binding. I've got a snug fit, fairly snug. Obviously it's not a resistance fit. But I've got a snug enough fit between the 1-inch axle shaft and these side plates. So if the hub is off concentric, if it's off center, I'm not going to be able to get the axle through here and through the hub and get it all bolted together without some effort. Obviously, I don't want to have that effort because that means the whole thing's off center. So take your time, be slow, be careful, get it right. Now I've just got the generator warming up. I got to do something about this shop power. And I've got this thing set up on a steel plate. I'm just going to attach my welder clamp to this. And I want to point out, before you weld anything, pay attention to the orientation of the hub. There's a keyway in there for the axle, and you don't want that keyway lined up with one of the keys you're about to weld on. Okay, the bolts are going in just fine. There's no effort or resistance. It's not given me any trouble trying to align them, so that tells me that things are pretty concentric. So what I'm going to do now is I'm going to take this thing apart again, and I'm going to do two things. What I'm going to do is I'm going to run a couple of tack welds along the length here, here and here, and here and here, to try and hold things where I want it to hold. And I'm going to grind down this stuff on the end here, because obviously that's proven to be a problem. I can't get the case to close because this is getting in the way of the step. So I'm going to throw a couple of tacks on here, and then I'm going to grind those off and refit it. Alright, so a little bit of grinding and test fitting later, and it assembles nicely. So now I'm going to burn in the keys, and I just want to point out to you that until the fitment is perfect, don't weld them in if you're going to use a welded method. Because if you weld them in wrong, you're going to put stresses in places stresses don't need to be, and things may end up breaking. So just keep grinding, test fitting, massaging until you get everything lined up right. Okay, so it's cool enough to handle now. Just give you a bit of a closer look at it here. As you can see, I filled in the void here with some weld. Cleaned off some of the spatter that was in the way of it fitting properly. And as you can see, the two set screws here are not buried under a key, which would be kind of silly. So I'm going to loosely assemble this. I did a test fit off camera while the battery was charging. I hate this camera, the battery goes really quickly. Anyways, I did a little test fit. So I'm going to run the assembly together and just position it on the axle just to show you that everything is where it's supposed to be. I'm just going to give you a note on assembling these things. This isn't the final assembly. I'm going to have to take it apart once I mark the axle, and I'll show you that in a second. But these 8 holes around the perimeter are actually not spaced evenly, and this could cause a little bit of frustration if you're not used to it. You've got groups of holes closer together instead of even spacing all the way around. So you're going to have to pay attention when you're putting this together. Pick 2 holes that are, for example, close together, and then look at the bull gear and pick 2 holes that are close together and line them up, and then you're in business. So we're just going to pop the hub in, and then we're going to pick 2 holes that are close together and get them on the same holes. And do that. Alright, so here we've got it located in the case. You'll notice that I haven't bothered with any of the 4 bearings yet because we just simply haven't reached that point. And all I want to do is try and find out where this axle centers. So on this side I've got just under 9 inches. On this side, nowhere near it. Alright, shove that over a little more. 8 1/8. So we're looking for about 8 1/4. Have 8 1/4 there. Just a little proud of 8 1/4. Just a little proud of 8 1/4. Close to 5/16. Okay. So we're going to call this located. This is positioned where we want it. So now we got to make some marks because we're going to attach the hub to the axle inside. But of course we can't do that from inside, and we can't see where it is on the axle right now. So what we're going to have to do is we're going to have to make some marks to figure out where this is all going to sit and figure it out from there, and then we can start banging bearings in and stuff like that. So I'm just going to mark the shaft where the side plate touches the shaft. Let's just get that gear out of the way for a minute. Give myself a nice big mark all the way around. Okay, cool. So now when we take this apart, we know where everything's going to sit, and we can kind of figure it out from there. So I'm going to take this apart. Alright, so here's what we've got. I'm going to leave the one side plate on so that we've got a reference. And I'm going to grab the hub. I'm going to stick the hub on. Now it absolutely doesn't matter which way this hub's facing, because it's going to index into the bowl gear no matter what, evenly, because we cut these keys to an exact length. Okay, so I've cut a piece of 1/4 inch key stock right here, and I've cut that to the inside dimension of the hub. So we'll find our keyway in the axle shaft and smack that in there. Now, we're going to align on the mark here, on the left side where I left that black magic marker. And just let that sit right there. And with everything in alignment, I'm going to tighten down the set screws, at least for a moment. Okay, so pull this flange off and get it out of my way. I'm going to give this a good snug on the set screw. Then I'm going to back it off, and I'll show you why I do that. What we've done, still a little snug here, probably because of the ding I just put in it, which was the point. There we go. Alright, so what we've done here, as you can probably see, I'll just bring the axle up to the camera, by tightening the set screw down, we put a little ding in the shaft. Now, what I'm going to do is what I always do with these things. Sometimes I do it with the drill, and sometimes I just do it with a file. But what I like to do is I like to put a little divot or a flat spot in the shaft where the set screw goes, and that gives it a little bit more of a positive location on the shaft. Instead of the set screw just trying to grab a round piece of shaft, I'm going to give it a flat spot or a divot to dig into. Alright, so we've got the blue number 242 Loctite. Pull the set screw out. Bomb a couple of drops of this junk on there and throw it back in. Alright, so with the hub in place where it's supposed to be in its rightful home, we can start lining up the holes, or attempting to, and get this thing bolted back together again. I definitely recommend doing these in a crisscross pattern when you're tightening them down, just to make sure you don't stress anything out too much in one direction. Alright, cool. Let's get this back in the case. For demonstration purposes, I've put the bearings back in, and yeah, there's definitely a thrust washer goes here. But anyways, you've got the factory needle bearings here and the factory double sealed roller bearings here, and we can see that this is running nice and true. We shouldn't have any issues with that. On the right side of the case here, I've put one of my factory wheel hubs back on. Obviously individual results may vary, but what I'm going to do here is I can see that in my application I'm going to have about 5 extra inches of axle sticking out. And eventually I'm going to trim that down. But the first thing I want to do is I want to get this thing installed in Fugazi. And I'm actually going to set my hubs to a width that I like. You know, obviously I don't want to go too far because now we're putting a lot of stress where it shouldn't be. But I may space these out a little bit for tire clearance. I'm not sure yet. But one thing I wanted to point out is getting back to, if you decide to do this weldless, with me welding the keys inside the differential carrier, I've made it so that the axle can't walk back and forth in the carrier. If you decide to go weldless, there's going to be some movement. You know, the hub is fixed to the axle with set screws, but there's a little bit of extra space in there. I think I figured out there was about 1/4 of an inch or so of play side to side. Now you've got some options there. You can fill that in with 1-inch bore washers until it takes up the extra slack so the axle can't move. Or you can go with one of a couple of different designs of lock collars. Now the split lock collars that are 2 pieces and they go together are actually better than these ones, but these are the ones I have available locally, so it's what I use. Now on these 820s, the end of the case is open. I'll just turn that towards you, and right at the end of the case is that bearing. So it is a perfectly viable option to put a lock collar right at the end there, riding against the inner race of that bearing. It's not going to be hitting the case, it's hitting the bearing, and that's actually a good thing. The inner race is turning, this is going to be locked against the inner race, so you don't need a thrust washer there, you don't need anything to space it off the case or keep it from interfering in the case, and that's perfect. So this is an option for you, and I'm probably going to use them to keep my hubs on. That being said, what I have to do now is deal with the fact that I've got this channel running down the entire keyway here because I used a piece of keyed shaft. So I've got a place that my oil can run out of the case, and I don't want to do that. So I'm going to get in here and I'm going to wash the shaft down with solvent. I'm actually going to use alcohol to get it perfectly clean, and I'm going to do the same thing I did in the Dock Locker 2.0, and I'm going to use this Permatex Ultra Black Oil Resistant Silicone, and I'm going to use that to fill the keyway underneath the bearings, and that way my oil can't get out. Alright, so that covers the portion of the dock locker for the 820 Transaxle. I'm not going to button this thing up yet because I still have a few things to do to it. I'm going to be running oil in it instead of bentonite grease, so I've got to go over all the seals and stuff like that and make sure everything's copacetic. And the other thing I want to do is I want to use the fender shifter that's on the Murray, that's on Fugazi, as it is. And I have noted that the MST Transaxle that's in there has a much longer shift arm, or actually the shift rod, the shift shaft that comes out of the Transaxle on the MST than there is on the 820. And in order for me to basically make use of the existing shift mechanism, because like I thought about changing it, believe me, but you know, I'm happy with it being right there on the fender. So what I'm going to have to do is I'm going to have to cut that shift shaft and extend it by another 2 5/8 inches. I already did the math on it. And then put a square boss back on top so that I can put the arm back on top and put it all back together again. So I've got to work on getting it oiled. I've got to work on extending that shift rod, install a vent, seal up the case, blah, 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 blah. And to prevent corrosion, I'm probably going to paint the case too. So I'm not going to button up the case today, so I'm not going to show you that. I'm pretty sure you can put a Transaxle back together. If you can't put a Transaxle together, you've got no business tearing one apart, right? Right. Download the Peerless Tecumseh Transaxle manual, the Peerless Tecumseh Drive Systems manual, and just go with the manual. This stuff's actually pretty easy once you've got the lay of the land and figure it out. So as far as locking the 820 goes, that's it for today. Thanks for tuning into Sprocket's Garage on YouTube. Don't forget to check out Sprocket's Garage on Facebook and visit sulphurcitydesign.com for your Sprocket swag. And until next time, take care of yourself.